All right, welcome back, sixth graders. We are continuing in Unit 8, finishing out today, Section 8.11, and today is Wednesday, April 22nd. All right, just as a reminder again, those vocabulary terms are on Quizlet. Make sure that you are studying them so that you are ready and prepared when the time comes to take a Quizlet test on them, which I will announce at a later date as we get further into the unit. All right, and so in the last video we spent a lot of time talking about light that is emitted from stars. We talked about the study of spectroscopy and how we use the spectrographs, or astronomers rather use the spectrograph to figure out which elements and how hot the different stars are based off of the light and intensity of light that they produce. All right, and so today we are going to keep talking about stars a little bit more, and starting with how we classify stars. And so in the 1800s, scientists began classifying stars, and the original classification system used the star's spectra, or that spectrum of light that we looked at in the last video. But they very quickly realized that this was not going to be a very reliable method. They were attempting to use those absorption lines on the spectra, and they realized that this wasn't really going to work out. So instead, there's several ways that astronomers use to classify stars now, and they do to some degree use the spectra, but they also use things like temperatures, they use brightness, they use magnitudes as well. And so on this slide here, you can actually see this is a temperature chart showing, how they classify stars. And so when you read in your text, you'll see that they assign a spectral type letter. O and B burn the bluest, while K and M are like the reddest. And this has to do with their temperatures in kelvins, okay? You'll see that this is in kelvins, not Fahrenheit, which is, if you recall from earlier this year, is another form of scientific temperature measurement that you may or may not be familiar with. It differs from Celsius and Fahrenheit. But this is just an example. You're not required to know this chart by any means or understand what it means exactly, but I just wanted to show you an example of just one of the few ways that scientists and astronomers are able to classify stars. Okay? And so how bright a star appears in the sky depends on how far it is from your observation location. And so for us, because we are not astronauts, we observe from Earth, right? And depending on where Earth is in its orbit, is going to dictate where we are relative to the stars. And so how bright an object appears to an observer on Earth, like ourselves, is called the apparent magnitude. Okay, and that's one of the vocabulary terms in your book. Scientists will use a star's apparent magnitude and the distance the star is from the Earth to calculate what's called absolute magnitude. All right, and this absolute magnitude of a star is the brightness measured by an observer that is at a standard of 32.6 light years away. And so this is great, it's a definition, but if we don't know what light years are, this definition doesn't mean a whole lot to us, does it? Right? And so on the next slide here, we're going to talk about exactly what a light year is. I've brought my friend Buzz Lightyear to join us for this little brief lesson. All right, and so we're going to actually jump down to bullet point number 3 here before I go back and explain, but what exactly is a light year anyway? How can we talk about absolute and apparent magnitude and not know what a light year is? Well, a light year, guys, is a scientific measurement that was not discovered, but was given by scientists to calculate distances that are much too large to use things like kilometers. Okay, you guys know that the universe is a very, very vast, large expanse, and so kilometers would be way too big of a number. We'd have these enormously long numbers that no one could ever read, and they would be a pain in the butt for scientists to work with. So they developed this new unit of measurement, and that's the light year, which has a very specific amount of time, and a light year can be defined as the distance that light travels in a vacuum in 1 year. And remember, I know you guys know this from previous science, but light is the fastest moving thing in creation. So the distance that the fastest thing in creation, light travels in a vacuum in 1 year, is a light year. And I do have a supplemental video that will help explain this even further, because I know it's kind of a interesting concept to gather, because we don't walk around here using terms like light year. Like I'll get to Canada in 2 light years. That's not a typical statement one would hear, because we don't use that on a day-to-day basis. So to help you understand that, I do have a supplemental video. But going back to what we were talking about on the previous slide about absolute and apparent magnitude, the dimmer the star is going to be the bigger the number for the absolute magnitude. And so very bright stars actually have really negative numbers, and that it's all in light years, but that's one of the ways that scientists study and figure out the brightness of a star is the absolute and apparent magnitude. And that has to do with light years. Okay. Scientists also have to study the position or the relative distance of where stars are. So where is the star in relation to where we are? And so we measure a star's position in relation to more distant stars. And so a scientist will measure a more distant star, and then 6 months later, when Earth is on the other side of the sun, they will measure its relative position a second time. And this is helping them build a picture of exactly the position of a star and its distance from Earth. And so from Earth, it looks as if the star moved, right? Because now 6 months later, the Earth has turned halfway around on its axis. And so we're in a different position. This has to go back when we talked about the hemispheres and the different equinoxes and how we get summer and winter, and that changes. And so this is the same idea where the Earth is now on the other side of the sun. And so from Earth, it looks as if the star moved. That apparent shift in an object's direction, when viewed from 2 geographically distant locations, is called a parallax. So the first time that the scientists have recorded its relation in comparison to a distant star, and then 6 months later, they did it again. So they have 2 geographically distant locations that they use to form this parallax. Okay, the different positions of a star as viewed from Earth and the sun are called the annual parallax. And this is a picture similar to one in your book, and it's very complex. Again, you're not required to understand this entirely. The diameter of the star, the orbit, the angle of its parallax, and very complex geometry are all used to determine a star's distance from the Earth. And so this is a very complex mathematical equation that scientists use, as you can see by this graph, it looks complicated, to determine the distance from Earth and a star. And so what they're showing you here briefly is in January, this is what you would see in the night sky. But because the Earth has rotated 6 months later, we are now in July, this is what you see. Do you see how it's a mirror image, but it's different, but yet the same, right? So we move and that perspective changes, and so it appears that those stars have moved in the night sky. And they can use this information plus that geometry and the parallax here to determine stars' distances. And so if you are anything like me, your head's probably swimming. This is advanced physics at its finest. Not something that we're going to tackle this year. And so you guys already know that Earth rotates on its axis, and that different parts of the planet's surface face the sun. We just said that, right? Because we're rotating, so different parts are going to face the sun at different times of the year. And so we see different stars in the sky at different times throughout the year. I mean, it's easy to look up and think that most of the stars up there are the same stars that were there 4 months ago, but we know that we are rotating, and so that's not true. From Earth, the North Star, which is formerly called Polaris, doesn't appear to move. So if you didn't know that, the North Star does not appear to move, and that's because of its position at the northern pole of the Earth. And I have another video to discuss this as well. But that makes the North Star a really prominent navigational tool. And you've probably heard of the North Star before, and you know that a lot of people use that to figure out where they are in relation to the sky and the other stars. And so it's an important navigational tool that we can use. But just know that stars do move in space. And not only do they move, but they change patterns. But that takes thousands of years. And because it takes thousands of years, the movement of the patterns is not obvious to us because we're not around that long. So we don't see that obvious movement. But there is movement of pattern changes, but the stars are just so far away, it's so minute we don't even see that. All right, and this is just a picture for you guys if you've never seen. This is an actual image from a night sky, and that's the North Star shining super bright. And so while all the other stars around the North Star will appear to rotate and move throughout the night sky as Earth moves, this one will remain constant right where it is. All right, so homework, fun stuff. You are to first and foremost read section 8.11, so that's found on pages 400 to 405. Okay, and then you need to complete the lesson review questions 8.11, and when you've done so, feel free to email those to me, okay? Seems to be that most of you are using Google Docs, which is great, so feel free to type up the Google Docs and share the link with me when you have finished them. And additionally, you need to watch the videos linked below, which will help better explain some of the complex things that we've just talked about in this and the previous video. And be sure to check back again on Friday for your next lesson and final lesson for this week. All right, I will see you guys on Friday.